Okay, for problem 52, we're going to solve for the acceleration of the system as shown here. We have three masses suspended over a pulley. The pulley is massless and frictionless, so we don't have to worry about the pulley in our calculation. So we have three masses, therefore we have three free body diagrams. We have two pieces of string, so we're going to label this piece of string tension 1, and we're going to label this piece of string tension 2. This pulley simply redirects tension 1, so tension 1 appears on both sides of the pulley. So drawing the free body diagram for the first system, we have an upward force T1 and a downward force of 5g, 5 kilograms times the acceleration due to gravity. I'm going to leave out the units here because it's easier um, to see without the kilogram floating around in there. Just remember your units have to be correct when you're done. Second diagram will be for the 4 kilogram. So the 4 kilogram mass upward is T1 and downward is 4 kilograms. Now, we will have to remember that the pulley redirects our positive and negative when we go from the left-hand side of this diagram to the right-hand side of this diagram. So when we're writing the equations for the second mass here, we're going to have to remember that the positive and negatives are backwards. The other option is you can draw all the forces in this diagram in reverse of what you see them physically occurring in the picture, in which case you will then get the positive and negatives correct. I'll stick with it this way. Uh, in addition to these 4 kilogram, I'm sorry, I wrote kilograms, 4g downward, we have an additional force downward, which is T2. And then our final diagram is T2 upwards and 3g downward. I'm going to write, we don't have any horizontal motion, so we only have to write some of the forces in the y direction in this case. So I'm going to write for this one, some of the forces is T1 minus 5g equals 5a. And it's equal to 5a here because the mass of this object is the 5 kilogram object. So I have one equation for T1 and a. Do the same thing for the second diagram here. And remember that upward was positive. Upward was positive here. And the pulley turns that around and causes downward to be positive in the right-hand side of this diagram, which means downward is positive and upward is negative in these equations. So I'm going to have minus T1 plus T2 plus 4g equals 4a. Again, this is the 4 kilogram object that's represented in this drawing, so 4 kilograms has to appear in the MA section. And I can write the same thing here. I get minus T2. Again, upward is negative in these diagrams, plus 3g equals 3a. Again, this is the 3 kilogram object, so that's what appears in the MA. I now have three equations with three unknowns. I can solve them. So here I have a mixture of T1, T2, and A. So I'm going to solve each of these two outside equations for their tensions and then substitute into the middle equation to get my acceleration. So T1 is going to equal 5g plus 5a, and T2 is going to equal 3g minus 3a. Algebraically, I took t over to the right-hand side here, which means it turned it into a positive, and then I brought 3a over to this side of the equation, which turned it into a negative. That's where I got that from. So now I'm going to substitute in here. So this is going to go in here, this is going to go in here, and I should get minus 5g minus 5a, because this minus sign has to distribute through all of T1, plus 3g minus 3a plus 4g equals 4a. So combining like terms, I have minus 5 plus 3 plus 4. So that should give me a plus 2g minus, and I have 8a equals 4a. So 2g has to equal 12a. So a has to equal 2/12 g, or 1/6 g. I can now use that to back substitute into my T1 and my T2 expression. So that gives me T1 has to equal 5g plus 5/6 g. So this is 5 and 5/6 g in terms of newtons. And T2 is going to equal 3g minus 3/6 g, which is going to equal, that's a half of a g, so this would be 2.5 times g. So T2 is going to equal 24.5 newtons, and T1 is going to equal, let's see, 57.2 newtons. And the acceleration is equal to 1.63 meters per second squared. Again, hopefully I've done all of my algebra and arithmetic correctly. There's my solution. T1, T2, and A.